Good evening.
Good evening to all of you.
So today we have the lecture on Indian Regional Navigation Satellite System IRNSS, or the commonly known as the NAVIC system, that is navigation with Indian constellation. So this lecture will be taken combinedly by myself and Dr. Kamal Pandey. So we both welcome you in today's session. So today we are going to cover the basics of the IRNSS system, what it is, what are the differences between the IRNSS and the NAVIC, what are the positional accuracies which we achieve with the IRNSS, different applications, and some of the case studies. So Indian Regional Navigation System is an independent regional navigation satellite system developed by ISRO India. So as of now, in the previous lectures, we have covered GNSS, wherein we saw the Navistar GPS, GLONASS, Galileo, BEDO. They were the global applications, whereas I have been talking about IRNSS and QZSS, that is Quasi-Zenith Satellite System, which are the two regional systems. So one among them is the IRNSS, which is the topic for today. Its operational name is the NAVIC, that is navigation with the Indian constellation, and it is providing us the standard positioning service and the restricted service for the authorized users in an area of entire Indian region plus 1500 kilometers from its boundary. And now it is a plan to be extended up to 3000 kilometers beyond the Indian boundary, so that it will benefit all the neighboring SAR countries also. IRNSS is providing the position navigation and timing service for various application and the users, benefiting them. It will provide the position accuracy to an order of 20 meter. So currently we are getting 20 meter positional accuracy with a timing accuracy of the order of 50 nanosecond. So these are the benefits with the IRNSS. The objective of the IRNSS is to provide reliable position, navigation, and timing services for the Indian and neighborhood region, as already discussed. It is planned in such a way that most of the constellation is seen by user all the time, so that with the minimum number of satellites we get maximum benefit. The best DOP, which is feasible using 7 operational satellites at a time, and this system is independent of existing GNSS systems. So that means it will be fully under the operational control of Indian government and the ISRO. So for this IRNSS system, we are using the geosynchronous orbit and the geostationary orbit. So geosynchronous orbits are basically inclined to the geostationary orbit at a same elevation of 36,000 kilometers. So we are using the 3 slots which we have received from the international agencies for the NAVIC purpose, and 4 satellites we are putting in the inclined geosynchronous orbits with an elevation of ranging from 19 to 29 degrees with respect to the equator. And these systems are providing the terrestrial, aerial, and marine navigation services, and is helpful for our disaster and fleet management systems across India and the neighboring country. If they are also using the IRNSS receivers, they will be equally benefited with it up to a distance of 1500 kilometers beyond the Indian region. And as just I told, we are in process of increasing this range from 1500 kilometers beyond Indian region to 3000 kilometers beyond the Indian region. Now the first generation satellites has already been launched, in which 9 satellites were launched, 8 were successfully operational, and 1 got failed actually during the launch. And now the second generation launch has started with the NVS-01. Earlier satellites were having a time period of about 10 years lifespan, whereas the NVS-01 has a expected lifespan of 12 years. Another difference is that the first generation IRNSS satellites, they were working on two carrier wavelengths, that is the L5 and S band. So that was creating some issue for interoperability with the other GNSS systems. So now we have received the sanction from the International Telecommunication Union, that is ITU, through the World Radio Conferences, for the usage of L1 also. So now L1 is also there in the NVS01, and in the second generation satellites, we are going to have all the three bands, L1, L5 and S band. So this is the first system which is using all the three for the purpose of pseudo range computation and the PNT services. So various the interface control documents has been brought in since August 2017 for the use of the various user agencies or individuals also who are capable of generating their own solutions. Since this information is shared through the ICDs, they can use the information about the IRNSS receivers, the coding scheme for their Android based devices. So various ICDs has been developed over time. Disaster alert ICD was also released in February 2021. The ICD for L1 also is released in the year 2022, from where this details we can check out that L1 also has a bandwidth of 24 megahertz as it was with the L5, whereas S band was having a bandwidth of the 16.5 megahertz. The navigation satellite data received from the IRNSS primarily includes the satellite ephemeris data, then the satellite clock correction parameters, satellite and signal health status, user range accuracy, and then the total group delay. Whereas the secondary navigation parameters include satellite almanac, ionospheric grid delays and confidence, IRNSS time offsets with respect to the UTC and the GNSS. So as in case of the GPS, we are going to have a offset in timing with respect to the UTC or the International Atomic Time. Then we also get the ionospheric delay correction coefficients as the secondary navigation parameter, along with certain other text messages, differential corrections, and the earth orientation parameters. Coverage we have already broadly discussed. It will be available in the Indian landmass entire and the neighborhood of it up to 1500 kilometers. So basically the footprint will be a rectangle from latitude 30 degrees south to 50 degree north and longitude 30 degree east to 130 degree east. So that is the basically service area where we are getting the IRNSS signals. Then IRNSS system provides dual frequency users with a targeted positional accuracy of 20 meters for 2 sigma. That is for 90% of the time the accuracy will be within 20 meters. This is one of the ICTs which was released in July 2019, that is having the details of the signal in space ICD for inchoate messages, because our fishermen have been facing a problem that they are moving into the region of the other country. They are crossing the Indian borders and the control within the ocean region, and they are being captivated by the other country. So they have a device now which will alarm them that they are moving away from the Indian borders. So they have different services such as high wave, cyclone warning service, and the tsunami service, and no warning. So that is already operational since the 2019. Similar to any other satellite based navigation system, IRNSS can also be understood in 3 segments, that is the space segment, ground segment, and the user segment. So space segment consists of the satellites from IRNSS 1A to 1I as part of the first generation of the IRNSS satellites, whereas the second generation NVS, so navigation satellite NVS 01, which was launched by the geosynchronous launch vehicle and F12 on May 2023. So now this is the second generation IRNSS satellite, which is enabled with the L1, L5 and S-band systems. So the first generation satellites were having a weight of about 1425 kgs and they were launched with the PSLV, whereas the new one are being launched by the GSLV. Our satellites are equipped with the rubidium atomic clocks and they also have the corner cube retroreflectors which help us in the accurate ranging for the satellites. These are some of the payload specifications. So L-band transmit frequency, S-band frequency and C-band for other communications are provided here with the antenna gain factors and then the polarization also. So RHCP polarization is used for the L-band and S-band. The modulation access scheme are also based on the CDMA, code division multiple access system. The time period for the pseudo random number sequence is 1 millisecond and the solar panels are generating a power of 1600 watts with a payload power requirement of 900 watts. So there is a surplus power which can be used when the solar power is less with respect to the angle of the power received from the sun. Now this was the last in the first generation series IRNSS 1I. So all these details you can see how systematically they are provided from the ISRO website and these can be checked out by any user for any kind of requirement. Now these are the details of NVS 01. So this is the first in the second generation series and the ICD for it has been released in October 2022 with the expected 12-year lifespan for the satellite. We are getting the signals in L1, L5 and S-band all the three. It is working on the I2K bus platform which is compatible with the geosynchronous launch vehicle which has our indigenous cryogenic engine. As well in this case we are having our own space qualified rubidium atomic clock which is generated by the Space Application Center Ahmedabad. So that's one of the bigger achievements which we are having in case of the NVS and we are getting a timing accuracy of the order of 50 nanosecond with it for 2 sigma. That is again for 90% of the time we are having an accuracy of the 50 nanosecond in this. So this diagram shows the basic design. So we have 3 slots at 34 degree, 83 degree east and 132 degree east. So these 3 slots we are using for the placement of our IRNSS satellites and then 4 satellites we are launching in an inclined geosynchronous orbit having an inclination between 19 degree to 29 degree so that we are having the view of the satellite from the Indian region for maximum of the time, which will benefit us in terms of having a good dilution of precision. We have discussed the DOP in detail in the initial lectures. Further, there is a plan to add more satellites to the IRNSS and bring the number to 11 so that we have 4 more spares at any point of time, because our basic scheme consists of the 7 satellites which was completed between the period 2013 to 2016. So from 2016 onwards we are getting the benefit of the IRNSS satellites. So various receivers has been developed by different government and private agencies which were relatively bulky in the initial cases, but then the miniaturization has taken place and now we have a chip which is fit for a usage in the mobile device also, and thus you have seen that the recent Apple 15 Pro model also is having the uh, IRNSS enabled features. So the design is so that we are getting the maximum benefit with minimum number of satellites for the optimal dilution of precision and as per the provided slots for the Indian region. This is the basic configuration or the architecture depicting the IRNSS user segment, which consists of the various users on the land, in the ocean, and in the air or in the space also. Because as I told earlier, in the satellites also we are putting the GPS or the IRNSS or the GNSS receivers, which provides us the position of the satellite also in their orbit. That is one of the way to know the position of a satellite in their respective orbits. Thereafter, it has lot of ground stations, which we will discuss in the coming slides for the CDMA ranging, IRIMS, and so on, along with the satellite constellation for the space segment. So, space segment, ground segment, and the user segment. So, the ground segment consists of the IRNSS navigation control facility and the IRNSS satellite control facility. They have various parts which we will see now. So, we have in the ground segment IRNSS navigation control center. The task of the INC is to estimate and predict the ephemeris data, calculate corrections for satellite vehicle clock, and maintain IRNSS time, determine the IRNSS free corrections, maintain the integrity, that is the mathematical correctness of the solution, then transmit the clock and ephemeris corrections to the telemetry and tracking center stations for uplinking to the satellites. Then IRNSS network time, so IRNWT is there, which is a set of ensemble atomic clocks providing us the time using the multiple clocks, cesium clocks and active hydrogen measure clocks. And now we have the rubidium clock also. Our own rubidium clock is also there. So as in case of the GPS, yesterday we discussed that there we are using about 200 plus clocks. So in case of IRNSS also we have few clocks from where we are having an ensemble solution to get the final timing, and that timing is provided as with the accuracy of 50 nanosecond for the 2 sigma value. So this IRNWT is the reference for all types of corrections being computed for each of the spacecraft. Then CDMA ranging stations are there, IRCDR. They facilitate accurate ranging for IRNSS satellites and send the data to the navigation control center. Then we have the IRNSS laser ranging service, ILSR, that provide the precise ranging of the IRNSS satellites using the international laser ranging stations. So currently we are using this service from abroad actually. IRNSS ranging and integrity monitoring stations, IRIMS, are there, which receive the data from the geostationary satellites and the geosynchronous satellites. They transmit the data to the navigation control centers in real time and facilitate one-way ranging for the all the satellites in the IRNSS series. Then further we have IRDCN, that is the data communication network, which connect the entire system with link level redundancy, equipment level redundancy, and changeover strategies or fail-safe mode. So that if there are certain failures in the data transmission, we always have a backup, that also in the real time. So if one line fails, we have a second line, second also fails, then we have a third line. So multiple level of redundancies are there for the data communication at our various centers all across India, which are linked to the main facilities in the Bangalore. Then IRNSS, TTC and land uplink stations are there in LESS. They receive telemetry from the IRNSS constellation. They are used for telecommand to the IRNSS constellation, and they uplink the navigation updates also. Then we have the satellite control centers. They manage and maintain the satellite constellation from the Bhopal center and the MCF Hassan. So this is again the architecture utilized for that. And here we can see that at IRS also we have the IRNSS IRDCN facility, which is available, and it is housed in one of our buildings at the IIRS Dehradun campus. Then the navigation center is located in the Deep Space Network, Belalu. The navigation center is functioning as the main ground station for the satellite system. So for the purpose of IRNSS, we can say that this is the major master control station kind of or the headquarter for this particular service. The navigation center is responsible for the time reference, generation of navigation messages, and monitoring and control of ground facilities, including the ranging stations. So that was the ground segment. So we have discussed the space segment, where we are maintaining 7 satellites. As of now, we have launched in total 10 satellites, out of which 9 launches were successful, and the latest one is the NVS-01. Now we have the different SPS receiver types. So currently we are using the single frequency receivers as L5 band IRNSS user receiver and the S band IRNSS user receiver, and dual frequency receivers are capable of getting L5 and S band also. So soon we will be receiving the multiple frequency receiver also. Currently we do not have here, wherein we will get L1, L5 and S band, all the 3. Currently we have spectra, precision and the accord systems, which are capable of receiving L5 signal in SP80, SP90 models, whereas in case of the accord system we are getting L5 and S band, both of them. Then the differential restricted service receivers are there. They are for the authorized users. They have dual frequency L5 and S band capability, and they have combined capabilities also along with the GPS. So IRNSS combined with the Navistar GPS, GLONASS and Galileo. So those receivers are also available, and soon we will have newer receivers also, wherein we will get the L1 capability also along with the L5 and S band. So that way we are going ahead with a good plan for the interoperability and different functionalities with the various GNSS services. So here on, Dr. Kamal Pandey will take you further. Thank you.
Yeah, welcome to all of you. As Ashutosh sir has discussed about the complete architecture of this IRNSS system. So from here onwards, I will just tell you about some of the applications of IRNSS or the NAVIC system, and one of the 2 use cases that we have conducted here at IRS with the data obtained from this IRNSS receiver. So first, if we talk about here, the basic goal of a GNSS is civil interoperability. So it is very essential that if we have a different kinds of this constellation system or the GNSS system around over the sky, then a user should not be bothered about their architecture. He should be able to get its location precisely. He can get a signal from a particular constellation. He can get the signal from another constellation, and once these signals are received, then its location should be generated. So our NAVIC system also fits very well into this interoperability, wherein even if 1 or 2 satellite signals you receive or the signals are received from some other constellation, even then your position is calculated. So it very much fits into that interoperability concept. So it basically says that better together than be separate. So so if you can see that it is very ideal. Interoperability allows navigation with one signal from each from 4 or more systems with no additional receiver cost or complexity. You might have seen in your mobile phones also, in the receivers also, you are able to get those signals from multiple systems. Okay, multiple constellations I am getting it, but the end goal is that calculation of your location. So that is very much true for our NAVIC system as well. So that talking about that, and the second component, the another one is, if we talk about this Gagan and the IRNSS, these are the two navigation solutions which are being provided by the ISRO. Gagan, as I think, I hope it might have been covered in your previous chapter, in your previous lecture sessions also. This is Gagan is totally independent of IRNSS. Okay, so basically Gagan is a SBAS system. It is only an augmentation system which improves the accuracy of a signal received from GPSs, whereas IRNSS is an independent system or the independent constellation of satellite which is giving you which is estimating the location information for you. Okay, so Gagan, you can say it is improving the accuracy of the location received from GPS, whereas IRNSS is an independent system which calculates the locations for the users. So now how does this, if we talk about the Gagan system, there the ground segment of Gagan, it comprises of INRES, that is Indian Reference System. So, or the secondly, it also has an Indian Master Control Center at Kundahali near Bangalore and Indian Uplink Station. So, these three systems are there in a Gagan system. We have seen in our IRNSS, we have a different set of systems were there, whereas in Gagan, we have only three systems. So, what these systems are doing, basically we have 15 reference stations in collaboration with Airport Authority of India, and what this 15 reference system, they are spread across the country, and they are continuously monitoring the atmosphere and the various layers of the atmosphere, and from that, once it is observing those conditions, it is calculating the correction parameters from those the layers of the atmosphere, and once these correction parameters are calculated or they are observed, they are uplinked to some geostationary satellites. Okay, there are two basically for the Gagan, and these correction parameters are uploaded to the two geostationary satellites. And now once when a receiver receives a signal from the GPS, and it is capable of getting the signal from the Gagan system also, then what it will do, it will receive some correction parameters from the Gagan satellites also. Okay, so signals from the GPS and corrections from the Gagan satellites, so your accuracy gets increased up. So that is the basic function. So you can say Gagan's user segment consists of the SBAS receiver. It should be capable of receiving the GPS signal and the correction from the geostationary satellites dedicated for SBS, this Gagan system. So data from this INRES is transmitted to INMCC, that is again this data is then processed by INCC and sent to INLUS, and then this INLUS transmit the corrected GPS information and time synchronization signal to the geostationary satellite. The complete flow, as I was telling to you, it then transmits the GPS like signals with an accuracy of order 3 meters horizontal and 4 meter vertical accuracy, and this is being extensively used for your by the Airport Authority of India in various like landing of the aircraft. At that that is a very crucial, wherein very accurate locations are required. So for that case, they are using this particular system. So you can just see what is the distribution of all those 15 reference stations across the country. So they are covering the entire country over here, and all the atmospheric conditions are measured from these 15 reference stations. So if we talk about the applications, okay, having talked about the Gagan and the IRNSS, now let us talk something about the applications of IRNSS or the Navik system. So there are numerous applications basically. If we say to list some of those applications, it is very much can be utilized for the terrestrial, aerial or the marine navigation. It means that wherever you are moving, so that movement can very much be can be supported with the help of this signals received from the Navik, whether it can be in the land or it can be on the air or it can be on the or on the water. Wherever you navigate or wherever you are moving, in all these places, these systems can help you in finding the in getting the directions and the location of your destination. Okay. Similarly, it also used for the timing services for financial institutions, power grids, and other government agencies. So this, apart from this navigation, it also provides you the timing services, very crucial in case of financial institutions, power grids, so and other government agencies. Similar, apart from that, now again mapping as usual. This mapping, surveying, geodetic data capture. So these are some of the other applications from which these NAVIC signals are being utilized. So if we say about the terrestrial navigation, it aids for the hikers and the travelers. It is also used for the Internet of Things based applications. Yes, you inbuild those NAVIC chips in that IoT devices, and then they can utilize those location information as well. Okay. And if we talk about the scientific research, they are useful for the atmospheric studies, crustal movement, how that crusts are moving. There are what is the status of the crust of the crustal movement under the surface, or it can also be a crustal deformation. So these two applications are very much can be carried out with the help of the signal received from the IRNSS. So like some more applications, if we talk about, like orbit determination for the satellite, for determining the orbits of the satellite, precision agriculture. Okay, this is again a very prominent coming up application wherein these NAVIC signals are being used. We can get one example. If I cite, like you can any agriculture farm you can select, and in that farm, if you are carrying your NAVIC receiver along with you, and some sampling you can perform on the in that agriculture field along with the NAVIC location, with the NAVIC device, which will capture the location information, and with that location information combined with that soil samples, they can be brought in back to the computer into your laboratory. That soil samples can be then can be analyzed using the in the laboratory, and various nutrients or various components of that soil can be extracted, like what is the pH of it, organic content, or sodium, potassium, and pK. So these can be analyzed in the laboratory, and once these values you get it, then you can just directly link it with that location information which was captured from the NAVIC, and separate maps can be generated, and which will be which becomes very useful during this precision agriculture practices. This was one example. Similarly, for the strategic applications, emergency services, disaster management services, I will show you an example where these the signal received from NAVIC or the Gagan, they were used for the disaster management kind of studies. Even we can also utilize them for the natural resource management, or vehicle tracking and fleet management, location based services in the mobile devices, visual and voice navigation for the drivers, even for the marine fisheries, precise business solutions, so like marine fisheries. So herein we are providing the solution to that, to the fishermen. Suppose like this particular NAVIC, it was very much utilized by the fishermen along the coast of the of this country, wherein whenever they are about to cross the international boundaries, an SOS message is sent to them, or so that they get alert over there. Apart from that, if they are lost somewhere in the services, they can also send one signal, and rescue services can be provided to them. So that kind of capabilities are available with this NAVIC systems, and it is being utilized in this coastal region as well. So if we talk about this Android app, so there is one example. If you see that Map My India, so Map My India and NAVIC, they have also developed one Android app which utilizes this the signals from the NAVIC constellation, and it can be used for various kinds of applications which were listed over here. Like so any of these applications, if you are taking this particular app, so it will provide you the location information from there. But the condition is that your mobile should be capable of capturing those receiving those NAVIC location information. Now if we talk for that, if I talk here, so you can just see that smartphones which are running on the new Qualcomm chipset, the new chipset that support the NAVIC includes like Snapdragon 720G, 662 or the 460. So apart from that, there are some coming up chips are also there which are capable of getting those signals from L5 also. Now in the new generation, as sir was telling, this NVS01, we have the L1 signals also. Okay, so I think in the coming days it will be more strengthened, and some chips apart from this, they will also be able to capture the location or the signals from the Navik constellation, so that location can be calculated on the real time. So if you see here some of the smartphone like Redmi Note 9 Pro with a Qualcomm Snapdragon 720, this is one particular mobile phone which is using which is capable of getting those signals. Similarly, MI we can say MI8 is there, Realme 7 Pro. These are some of the mobile phones which are capable of receiving the signals from this Navik constellation. If you say we had performed one experiment on that experiment was performed by our one center called Space Application Center Ahmedabad. So that in that experiment they were able to achieve the accuracy of the level of 1.5 meter using that mobile phone called MI8. Okay, so that much accuracy they were able to achieve from it. Let me come here. So your phone should be capable of should have that Snapdragon chip, or you should have that particular phone. Then only this app will be usable for the Navik for receiving the signals from the Navik constellation. Now another case study that we have done with one of the receiver that we have received at IRS, that was for both for L1 and the S band, sorry, L5 and the S band. That accuracy assessment we were trying to perform. So here you can see that at every second we are getting one signal from the Navik. Okay, so at every signal that point is mapped here, and you can see there is the x-axis, this is the latitude, and these are the y coordinates. So x and y coordinates we have plotted, and you can see here that the location is coming towards it is only in one quadrant itself. So the accuracy is quite good in this case. So this is a 1 hour observation here, and again here we have from the S band also we are having a comparable accuracy over here. You can just see it is not going much beyond, although we have just zoomed that part, that's why you are able to see that elongated portion over here. But this exercise was carried out long back in around 2016, that exercise was carried out. Now by this time that has improved quite a lot, and we are able to get much better accuracy from this constellation. So we performed that at that time. You can just see in 2015 or 16 we were having, this was that receiver of the Navik. Okay, and here we had one instrument that was from the Accord that was able to log all the signals captured through that Navik constellation. There was one small battery was there, and once it was logging it, then the data we were able to pass it to the laptop, and from there we were able to perform that 1 hour analysis. So I was telling to you earlier also, like we have some GPS, GLONASS and Gagan receivers as well in a single chipset. Okay, so this is basically high performance fast TTF IRNSS GPS GLONASS receiver is available in the market. It supports around 40 channels, 16 GPS, 14 GLONASS, 7 of IRNSS and 3 of the SBAS system. It has an active antenna port for interface to GNS antenna, and this antenna is open circuit detection. This is short circuit protection is there, lightning protection is supported in that. It provides GPS, GLONASS, IRNSS and the combined navigation solution that I was telling to you earlier, that interoperability. So in the single chipset we have all the signals, and through that interoperability we are able to get the location information. Power on BIS support with support hardware outputs, signal of around 5.0 volts input supply is there. That antenna supply 5.0 volt we can say, and secondary UART for for the message input and output. It also support, this is important here, very open format called NEMA 0183, and it proprietary messages also, and this all controls this particular chipset is having. This I told you earlier also, we can have different types of receiver for the this Navik. We can have a dongle also here, like you can have USB dongle. This you can just put it into your laptop, and your full laptop will become a Navik receiver itself. The same is true with other constellation also, but herein I am just showing it one dongle which is developed by one company called Accord, and this dongle is capable of getting those signals from the Navi constellation. We can also have the same in the form of a Bluetooth device like this displayed over here. You can carry on this Bluetooth device, you connect it to your mobile or to your laptop, and your signal will be there in your devices also as well with the help of these Bluetooth devices. So now if you see about here, now this Navig GP, there is one international international body which governs this navigation signals basically. So that is known by the 3GP, third generation partnership program, and the Navig. If you say that global standards body, it is GPP, it has approved the India's regional navigation system developed by ISRO. And what is the implication of that? The implication of Navig acceptance by 3GPP would bring the Navig technology to the commercial market for its use in 4G, 5G or any kind of Internet of Things. So this is a very big good achievement over here, which will help us to get in those GPS signals, so this Navig signals in your mobile phones as well. So another example, I was telling to you accuracy assessment of that. So if you can see here, in June 2016 we performed this accuracy assessment and positional accuracy. Although it was told in the document, it is documented that it gives better than 20, but we were able to get the positional accuracy of 3.5 meter with Navig in the L5 range, and similarly for the height we were able to get it 3.155 this level of accuracy we were able to get it over there. So the interface you can just see here, there are apart from the other like GPS or the S-bus, we also have that installation, the IRNSS constellation. These red ones are displayed over here, 1, 2, 3, 4, 5 are displayed along with the other. This is the sky plot available in that particular interface of that plot. It is now available in most. There is one another GPS test or the GNSS Connect kind of mobile apps which will allow you to see this sky plot, wherein you can see what is the status, how your satellites are visible at which location, that it displays. They get displayed over this sky plot as well. So it was some example. Another case study that we have performed in the kinematic mode in the northern Himalayan roads. So from this Dehradun we started like 2 case studies we have taken. One was from Dehradun to Mussoorie, which is at the elevation, the difference of elevation between these 2 points is around 1000 meters. So Dehradun is around 700 and now Mussoorie is at around something called 1700 meters. So that elevation is around 1000 meters. And similarly from Dehradun we went to this Gaurikund. Here also the elevation difference is of 1000 meters only. But this you can see the ground distance, it is quite long, around 250 kilometers, whereas the same elevation difference here we have around 35 to 40 kilometers maybe, 40 kilometers. So the same thing, 1000 difference of elevation in 30 kilometers and same 1000 difference of the elevation in around 200 to 50 kilometers, 250 to 300 kilometers distance. So there also these road sectors were selected. You can see here, obviously we might be having very crisscross roads from in this particular path from Dehradun to Mussoorie, whereas here in this particular path we have the deep valleys, the road is going along those along the river towards there are different confluences also, like Devprayag is there, Rishikesh, Rudraprayag, these are different confluences, and these road is going along that river only. So here we have very high mountains are there. So we were trying to test that how your signals are behaving in these kinds of terrains. Okay, so if you see it here in that terrain, we could get a very good accuracy. You can see this cyan color. This is the accuracy we got it from the IRNSS, and those pink color from the GPS, and similarly the Gagan receiver is also there with the green color. So all are in line here. So the accuracy are very much comparable. So during at this particular, and similar was the case with the other route also, that was from Dehradun to Mussoorie. The similar kind of accuracy we were able. It means the signals is able to get the signals from IRNSS. When we plotted, those came similar to the mapping as we get from the GPS or the Gagan signals. So you can just see in the field in this graph as well over here. Similarly, as I was telling to you, for the one another application, the real time application that was performed, that project that during that 2013 disaster, although this IRNSS was not functional at that time, but that Gagan signals we were able to get during that period. So for mapping those disaster hit areas in 2000 Kedarnath disaster, so that at that time a mobile app was developed in which that Gagan signals were Gagan signals were embedded over there, and the accuracy of those disaster hit points was measured with that Gagan enabled GPS signals. Okay, so you can say the end was used input towards formulating the guidelines for restoring the development activities. It was from the Department of Science and Technology, Minister of Science and Technology, and detailed around 7 river valleys of Uttarakhand like Alaknanda, Mandakini, Bhagirathi, Yamuna, Ganga, Pindar and Kali Valley. They all were mapped with that Gagan enabled GPS receivers, and when we overlaid those signals on this Cartosat 1, 2 or the LIS 3 or the LIS 4 satellite images, we were able to map those damaged points very accurately. Similarly, you can see the architecture was that it was able to capture the location or point and line. All the three features of the GIS could be that the app was developed in such a way that it could capture the point, line or the polygon, both all the three features, and that too from the Gagan enabled GPS receivers. So you can see here we were able to map around 16,000 points in the duration of around 3 months, and how they were located in this Bhuvan Geo portal. It is from the Dehradun region, again mapped from somewhere here from the Dehradun, and again in this all those seven valleys, all these points were located here, and then they were further analyzed. Although that analysis I am not discussing over here, but they were analyzed what could have been the reason for this disaster and how they can be restored further. So that complete exercise was performed using these kind of signals. So now with this I come to the end of this particular session. Thank you very much. We will